Good morning all and welcome to our COP26 Built Environment webinar. Thank you for joining us today. Before we get started and I hand over to our host Tom, we would like to quickly just highlight some housekeeping. We have a Q&A function available throughout today's webinar where we would encourage you to ask any questions. Questions will be taken at the end once all presentations have concluded, with our session facilitators Jennifer and Rebecca keeping an eye on these throughout. Should your question not be answered where we run out of any time, we will look to get a response to you post-event. With that in mind, I will pass you over to our host and Head of Carbon and Sustainability at Graham & Sibbald, Tom Meney. With a background in engineering, procurement and environmental management consultancy, Tom boasts a wealth of experience having worked in the environmental sector for the last 20 years. Formerly the owner and managing director of Carbon Zone Limited, Tom joined Graham & Sibbald in the summer of this year and provides a wide range of services, including environmental compliance and audit, energy efficiency assessment and carbon accounting, risk management and management systems implementation, and much more. Over to you, Tom.
Thank you, Jen, and hello everyone. Thanks for joining us on the eve of the end of the first week of COP26, which is actually taking place probably less than a mile from our own office over in Glasgow. So I just want to say welcome to everyone and thanks for joining our own little COP conference, which is going to be focused around the built environment and its impact on the UK's ambitions to achieve net zero status. But first of all, my most important task of today is to introduce our speakers. We have a fantastic variety of speakers coming from a variety of knowledge and experience in planning, architecture, energy efficiency, urban regeneration and future design. So let me go through a couple of minutes worth just giving you some details on the speakers themselves. So first up is Kerry McGuire. Kerry's going to introduce planning as a driver for low carbon development, and Kerry is a partner and the head of planning and development at Graham & Sibbald. She's got more than 17 years of experience as a chartered planner and a chartered surveyor, offering planning and development consultancy services. Having studied environmental planning at the University of Strathclyde, Kerry's career has seen her work in some of the industry's key names, and her current role sees her providing a wide range of services across both the public and private sectors, from site finding and preparation of planning applications and appeals to undertaking environmental impact assessments and general consultancy advice. So we'll hear from Kerry in just a few moments. Next up is Andrew Daly, who's going to discuss the developments in building standards for a net zero future. Andrew is our head of architectural services based in the Glasgow office, but he delivers projects on behalf of clients throughout the UK. He's got over 19 years worth of experience in the construction industry throughout Scotland, and he joined Graham & Sibbald in 2002. He specialises in architectural technology and design, and Andrew takes construction projects from initial brief through to design, planning, warrant, tender and construction phases through to completion. His work varies from industrial to commercial sectors, retail and redevelopment up to new build projects. Following on from Andrew, we've got Pamela Mathieson, who's going to be discussing tackling emissions from an existing built environment. Pamela is an associate with Graham & Sibbald in our new Carbon and Sustainability department. Already with more than 10 years of experience in environmental compliance and energy efficiency consulting, Pamela went on to do a postgraduate in environmental management, leading to an MSc in the discipline. Most recently, she's worked as an environmental sustainability advisor with BAE Systems and has extensive experience in the provision of support and advice related to environmental and energy management systems, carbon footprint assessments, and the delivery of net zero carbon strategies on behalf of a wide range of clients. Then last but not least, of course, is Dr Marie Macklin, who's going to be discussing the future of building design and her personal experience of delivering the HALO project. Dr Macklin is a groundbreaking business leader who challenges conventional thinking. Her commitment to the environment and to young people is bringing hope to communities throughout the UK. Back in 2014, she was awarded the CBE in the Queen's New Year's Honours List for services to economic regeneration and entrepreneurship in Scotland. 13 years in the making, the HALO project in Kilmarnock is a £63 million urban generation scheme designed to maximise collaboration between entrepreneurs and UK listed companies, setting a high standard for low carbon energy sites to create sustainable communities powered by renewable energy. That is our list of speakers today, and I'll be grateful to pass on to Kerry just in a few moments. Jen, could you go to the next slide, please? So before going into the presentations with each of the speakers, I thought I'd give you a little bit of context as to what this discussion is all about, and specifically at the moment what COP22 is trying to achieve. COP26, I beg your pardon, 4 years behind there. So COP26 is, you know, we're used to seeing politicians standing on stage and talking as if their life depended on it, but this conference is actually very crucial for the world. We are expecting from this commitments from governments, institutions and big businesses globally, agreements to try and achieve a limit on temperature increases this century of 1.5 degrees. Failure to do that can be catastrophic for our environment, so it is a very critical conference, and this particular one, driven by a UN scientist report at the start of this year, is essentially positioned at the tipping point where we think action now or failure to act now is going to result in potentially catastrophic results if we cannot maintain a 1.5 degree limit. Yesterday's focus at COP was on the transition to clean green energy, and interestingly enough, this is the one area of decarbonisation that the UK has made a significant inroad into over the last few years. And at this point in time, I'd like to go into the background to what UK are actually doing in regards to addressing climate change. So Jen, if you could move to the next slide. Excuse me. So looking at this particular slide, we have a couple of key text points here. The UK has legally set a binding target to achieve net zero by 2050. Scotland, the devolved government of Scotland, has also set a net zero target slightly ahead of that by 2045. And if you look at the graph on the right hand side here, what you can see is the journey from 1990 to today. And so that's over the last 30 years, and the emission reductions that have taken place as a UK emission inventory in total. Now that reduction actually takes us from around 800 million tonnes to just over 400 million tonnes in the last year as a provisional figure. That progress is about 48.8% change, so all looks good on the face of it. However, looking a bit deeper under the figures there, if we look at where we need to be by 2035, which is the interim target set by UK government, we need to be achieving a 78% reduction in emissions. So in actual fact, now thinking about that, we've got to reduce the carbon emissions that we're producing from this year by 30% within the next 13 years. So it's taken us 30 years to achieve 48. We now have 13 years to achieve another 30. So there is a long way to go and a lot of reduction to take place. So looking down at the graph at the bottom there, you'll see a blue line extrapolated out from 2020. That essentially is the current path of future emissions as we see fit. Currently, the decarbonisation of the electricity supply has led to most of the reductions you can see in previous years. The problem now is that we're relying more and more on other sectors delivering carbon reductions of an equivalent amount. And that's where we need to get back on path, that red line there showing us a much steeper progress towards the 2050 target. Jen, could you move to the next slide, please? So looking at the built environment in the UK specifically, what is the impact of that? So looking at, in the context of all emissions from all sectors within the UK, the built environment accounts for about 26% of that. Now that's including both direct emissions from the combustion of fuels, mainly to heat buildings, and from indirect emissions in terms of powering those buildings, lighting, IT equipment, and various other aspects of powering our buildings. So 26%, that's a massive share of the UK total. And the main point here is that decarbonising this sector is going to be critical to the success of meeting a net zero plan. Over on the right hand side, you can see a pie chart there with current EPC bandings in it. This is an interesting statistic and focuses on non-domestic premises. So these statistics are coming from both the UK government and Scottish government's reviews of non-domestic properties and the EPCs that have been performed on those buildings. It turns out that looking at England and Wales, about 70% of the non-domestic building stock is performing at level D or worse, which isn't great. Looking at the Scotland figure, it's even worse because 86% of Scotland's non-domestic buildings are rated D or worse as well. So we've got a long way to go to improve the performance of our non-domestic building stock. Next slide, please, Jen. So I mentioned before about the progress we've made in decarbonising the electricity supply. If you look at the graph on the left-hand side, that shows us the electricity generation decarbonisation route, and you can see a very steep decline over the last few years in electricity carbon intensity. However, as I said before there, at this point in time, we can't rely simply on the gains made by electricity generation decarbonisation. We've got to look to other sectors now. So we've got laggards in there, particularly in the case of surface transport, aviation, for example, and the built environment. The orange line in the centre of that graph actually shows us the built environment, and while we can see some slow progress over the first 20 years of our journey, actually in the last 10 years that has levelled off, if not plateaued altogether. And the average rate of change on the bar graph beside that shows you a very little decline in carbon intensity in the built environment. Looking at the grey graph to the right of that, I've honed in now on the last 10 years, so from 2010 to 2020, to show you in more detail the decarbonisation effect of the built sector in that period. And we can see that in actual fact, since about 2014-15, we've made no progress at all. And in fact, in 2019 and the provisional figures for 2020, it suggests a very slight increase in emissions in the built sector. So what does that mean to us in terms of overall net zero strategies? If you look at the graph below that, this is back to the UK picture for the built environment and our emissions reductions in the building environment. If we continue on that path that we've created for ourselves in the last 10 years, we're going to follow the blue line extrapolated out to 2035, 2040, and that shows very little, if any, progress whatsoever. So in fact, what we have to do in order to keep the UK on a net zero path by 2050 is that the built sector actually needs to be reducing its emissions by 41% from the 2019 level to 2035. So 41% in 13 years, as opposed to what we were talking about earlier, the whole of the UK having to achieve 30%. So the built environment sector is going to have to outperform the rest of the UK in terms of decarbonisation in years to come. Next slide, please, Jen. So what to expect, really? I mean, what are government doing about this situation? Because they realise as well as we do, because they have these figures, they generate these figures. What are we going to do to get back on track and to achieve that net zero position? Well, we should expect a lot of policy development at government level, feeding out into regulation, particularly regulation in respect to the adoption of energy efficiency measures, tightening of planning requirements and building standards, two subjects we're about to discuss with the next two speakers, an uplift in minimum energy efficiency standards. So that's going to be forced upon particularly landlords in the non-domestic area as well as in residential sector. Application of enforcement measures, so going from the softly approach to actually applying penalties where non-compliance exists. Government incentives as well, so it's not all about the stick, some of it's about carrot. So there's a range of government incentives in place to help grant or part fund or to provide zero interest loans for making energy efficiency measures happen. And then lastly, what we're seeing is that pressure from investors who are striving to invest in sustainable and green investments, they're now demanding certain performance levels from the recipients of their funds, and particularly green lenders as well, such as the banks, looking at favourable rates on mortgages and the likes as well. So we should expect to see all of this happening in the next decade or two. So without further ado, I'd like to pass on to Kerry, who's going to take you through the planning discussion. Thank you.
Thanks, Tom. As a planner, I'm probably somewhat biased about the importance of the role the planning system can play in delivering a low carbon future. The Scottish planning system, alongside building regulations, is one of the key controls and influences in delivering low carbon developments. I will briefly cover the Scottish Government's current national planning policy position in relation to delivering low carbon places and how this is evolving in the emerging National Planning Framework 4. I will also briefly look at how this has been implemented at a local level. Next slide, please. The National Planning Framework 3 was published in 2014 and is a long-term plan for Scotland that sets out where development and infrastructure is needed to support sustainable and inclusive growth. Scottish planning policy was also published in 2014 and sets out the national planning policies for the development and use of land, and this is a non-statutory document. Both documents here are a single vision for the planning system in Scotland. This puts the low carbon economy, reducing emissions and creating sustainable places at the heart of the planning system. Next slide, please. National Planning Framework 3 identifies that planning will play a key role in delivering the Scottish Government's carbon reduction commitments. NPF 3 links the planning system to the Scottish Government's climate change policy and associated targets. The framework recognises that technological innovation is fast-paced and that the Scottish Government's strategy must be flexible to adapt to change and make the most of new opportunities. And I'll leave you to be the judge if this has been achieved. NPF 3 identifies that cities will be exemplars of low carbon living and the focus for essential energy infrastructure. It is recognised that there's a significant opportunity for reducing emissions through retrofitting efficiency measures for the existing building stock. Scottish planning policy establishes that one of the key outcomes of the planning system is to deliver a low carbon place. SPP sets out that the planning system can support the transformational change required to meet emissions reduction targets and influence climate change. The planning system can also influence people's choices to reduce the environmental impact of consumption and production through energy efficiency and reduction of waste. In delivering a low carbon place, SPP sets out that the planning system should support the transformation of change to a low carbon economy, support the development of a diverse range of electricity generated from renewable energy technologies, guide development to appropriate locations, and help reduce emissions and energy use in new buildings. Next slide, please. The position statement for National Planning Framework 4 was published in November 2020 and sets out the direction of travel for the emerging framework. NPF 4 will incorporate Scottish planning policy and will have the status of a development plan, and this is a change from the current position and strengthens the role in informing day-to-day planning decisions. The position statement is clear that climate change and achieving net zero emissions by 2045 will be the key focus for the planning system and guiding principle for the preparation of all development plans and making all planning decisions. The position statement identifies key opportunities for the planning system to support net zero targets. Examples of opportunities include building 20-minute neighbourhoods, strengthening support for retaining and reusing existing buildings, shifting future development away from greenfield land by actively enabling the redevelopment of vacant and derelict land, expecting low and zero carbon design and energy efficiency in new developments, strengthening policies to secure low carbon heating solutions, supporting renewable energy developments, and also removing the need for planning permission for active travel and EV charging points. The draft NPF 4 was expected to be published for consultation in autumn of this year, and the exact timescales for publication and consultation are not known at this stage. I did wonder if they'd be published in time for COP26 and I'd have to frantically rewrite this presentation, but thankfully not. As always, the devil will be in the detail, and it'll be interesting to see the policy stands taken within NPF 4 in relation to tackling climate change and developing low carbon places. Next slide, please. I will now briefly look at how the national policy position in tackling climate change is filtered down to individual local authority level and addressed within local development plans and planning application decisions. The majority of the existing adopted local plans across Scotland contain a low and zero carbon buildings or resource management policy. In general, these policies are currently only applicable to new buildings and not to alterations, conversions or change of use. The policy requirements are usually linked to building standards and generally require CO2 emission reductions through the installation of low and zero carbon generating technologies. The reduction requirements differ between local authorities and in general include a sliding scale of CO2 emission reductions generally ranging between 10 and 20%, with a reduction percentage requirement increasing over time. The preparation of new local development plans is broadly stalled across Scotland until the NPF4 has been published, and also there's more certainty in the plan making regulations associated with the implementation of the Planning Scotland Act 2019. A small number of local authorities are forging ahead with their plan preparation, and hot off the press is the Edinburgh City Plan 2030, where consultation is due to commence on the 7th of November. The emerging city plan for Edinburgh is an example of the strengthened national policy position being implemented at a local level. The emerging Edinburgh City Plan puts addressing climate change at the heart of the plan. Edinburgh City Council has set a target for the city to be net zero by 2030. The proposed plan identifies that this will be achieved through various objectives, including delivering 20-minute walkable neighbourhoods, delivering development in brownfield rather than greenfield land, and requiring all new buildings to be net zero and delivering heat networks and energy infrastructure developments. This very much echoes the opportunities set out Scottish Government and the NPF4 position statement. The adopted Edinburgh Local Plan 2016 contains policy DAS 6 on sustainable buildings, which requires proposals for new developments to demonstrate the current carbon dioxide emission reduction targets are met, with at least half of this target being met through the use of low and zero carbon generating technologies. The emerging proposed plan retains this policy through policy ENV8, new sustainable buildings. This revised policy strengthens the requirement that all new buildings are sustainable and achieve net zero levels of operational greenhouse gas emissions through fabric energy efficiency. The policy also requires that consideration is given to the use of green roofs. The proposed Edinburgh City Plan also introduces a new policy, ENV7, on sustainable developments. This policy goes beyond the current approach adopted by most local authorities, which generally only apply carbon reduction requirements to new build developments. Policy ENV7 of the Edinburgh City Plan requires all proposals involving construction or a change of use to incorporate all reasonable practical measures to address the climate emergency. This policy requires the submission of a sustainability statement to demonstrate that the proposal integrates measures to mitigate and future-proof the building against the effects of the climate emergency. It also requires encouragement for active travel. This is a significant change that will impact on the majority of planning application submissions in the city, and something that applicants will have to address within their planning application submission, even for relatively minor proposals such as a change of use. The adopted Edinburgh Local Development Plan contains a policy on sustainable energy. This has been retained and expanded to include heat networks. Policy INF 16, Sustainable Energy and Heat Networks of the emerging Edinburgh City Plan, supports the principle of low and zero carbon energy schemes, such as small-scale wind turbines, solar panels, ground and air source heat pumps. The policy also states that all new developments should connect to existing or planned heat networks. Where this is not possible, then all substantial developments, such as new towns, urban expansions or large master plan sites, should include a source of renewable or low carbon heat generation and associated heat networks within the development itself. This will be subject to a viability and feasibility study. Anecdotally, and similar to Edinburgh City Council's approach, we are starting to see more local authorities requesting sustainability statements and evidence of carbon reduction as part of the planning application submissions, and this requirement is usually identified during the pre-application discussions. Authorities like Fife and Perth and Kinross have a requirement for submissions of low carbon sustainability checklists before planning applications can be validated. We are also seeing carbon emission reduction conditions being attached to planning consents more frequently. One of our most recent consents for a roadside services development at Falkirk had a condition attached that required a minimum of 12% of CO2 emission reductions to be achieved through the installation of low and zero carbon generating technology. In summary, it's clear that the Scottish planning system has a key role to play in addressing climate change and delivering low carbon places. Addressing climate change is rightly at the forefront of the emerging national and local planning policy. If the proposed Edinburgh City Plan demonstrates the direction of travel for local authorities at a local level, it is clear that sustainability and energy efficiency will be a key material consideration in the determination of planning applications for all development proposals and not just new builds. Applicants will need to consider this from the outset in the design of their development, and this will need to be evidenced as part of the planning application submissions. I now pass you over to Andrew Daly, who will be discussing the building standard requirements.
Thank you, Kerry. Good morning, everyone. As Kerry said, I'm discussing building standard developments for a net zero future. Next slide, please, Jen. So what are the current aims of Section 6 in the building standards? To have an effective measures to conserve fuel and power to be incorporated into buildings, to limit energy demand, to have a holistic approach to design. Designers of new buildings are obliged to consider building design in a holistic way, and to consider the benefits of low carbon equipment, photovoltaics, solar, water heating, combined heat and power, heat pumps, towards meeting standards. Next slide, please, Jen. The standards themselves are split into two sections: for dwellings, domestic, and commercial buildings, non-domestic. Each set of separate standards has a method of calculating carbon dioxide emissions, either a standard assessment procedure, known as SAP, for dwellings, or a simplified building energy model, SBEM, for commercial buildings. There are emission rates for each proposal: dwelling emission rates, or DER, for dwellings, and building emission rates, BER, for commercial buildings. These rates should be less than or equal to the notional dwelling or notional building. This is referred to as the target emission rate. Next slide, please, Jen. Current building standards minimum backswap U values are shown in blue in these tables. Backswap values in 2007 are also shown in red for comparison over the last 14 years. Notably, domestic values have reduced by approximately 25% over the period. However, non-domestic values have reduced by approximately 10% over the same period. These backswaps need to reduce further and faster to improve the performance of the fabric if we are to achieve climate change goals. Next slide, Jen. So the challenge. There are around 27 million dwellings in the UK, 80% of which will still exist in 2050. At present, these dwellings represent approximately 27% of the UK CO2 emissions, and about 15% of the UK CO2 emissions can be attributed to the burning of fossil fuels to provide space heating and housing. As current rebuild rates are delivering only approximately 120,000 homes per year, we clearly cannot rely on new builds to deliver the seismic shift needed to achieve targets set by the Climate Change Act. If we consider the targets set out in the Climate Change Act and subsequent international agreements, such as the Paris Climate Agreement 2015, existing buildings need to be zero carbon by 2050. But if all existing buildings were upgraded to zero carbon, this would mean that over 2,000 buildings per day, every day, until 2050 would need to be upgraded to meet this target. So how do we actually upgrade the existing building stock to zero carbon levels? Next slide, please, Jen. What is retrofit? Retrofit is distinctively different to refurbishment or repair, which have traditionally been the methods used to treat existing buildings. This has generally been either for essential maintenance purposes or for cosmetic reasons, to update or modernise the appearance of the building. Instead, retrofit aims to upgrade an existing building to meet wider objectives, reduce energy consumption and improve thermal comfort. Retrofit also typically includes other works, including essential maintenance and improvements to the aesthetic appearance of the building, which are carried out at the same time. What is the cost? Retrofit is typically cheaper than demolition and rebuild. While there may be other reasons to consider redevelopment, such as increased density, it is usually more cost effective to refurbish. Next slide, please, Jen. So what's the approach? Fabric first, involving maximising the performance of the components and materials that make up the building fabric itself, before considering the use of mechanical and electrical building services systems. This approach can help reduce capital and operational costs, improve energy efficiency, and reduce carbon emissions. A fabric first method can also reduce the need for maintenance during the building's life. What methods do we use? Maximising air tightness, fabric envelope improvements, thermal bridging improvements, optimising solar gain through the provision of openings and shading, optimising natural ventilation, using the thermal mass of the building fabric, using the energy from occupants, electronic devices, cookers and so on. Passivos and Enerfit. These are ultra-low energy performance standards, which also adopt a fabric-first approach and are key to achieving climate change goals. Next slide, please, Jen. Quick background on Passivos, which was originally developed in the early 1990s by academics at the Lund University in Sweden and the Institute of Housing and Environment in Darmstadt in Germany. The methodology incorporates all aspects of the physical performance of a building in its local context, using local weather files suited to each location. The standard requires a highly insulated, airtight building envelope with a mechanical ventilation system to provide heat recovery. Certification. Kerri and Sibbald have in-house certified passive house designer, and we also have an approved certifier of design for Section 6 energy with RDSAP accreditation for existing buildings. Next slide, please, Jen. So what are the passive house principles? Building envelope. This should be a continuous layer without gaps around the building, which minimise heat transfer relative to the function of each element, whether it's a window, wall, roof or a floor. Threshold levels of performance are required for each element to ensure overall integrity. In the case of windows, this includes performance losses arising from installation into the wall. The efficiency of the envelope relative to the floor area, often known as the form factor, also plays a part in reducing demand. Air tightness. The airtight layer plays a crucial role in reducing heat loss from drafts as well as protecting the building fabric from condensation. The measurement of air tightness should be done at key stages during construction, for example shell stage or fit out stage, to ensure that performance on completion meets the threshold criteria. Solar gain. Windows are typically required in all building types, and seasonal variations need to be carefully modelled to provide sufficient heat in the winter while providing overheating in the summer. In practice, this can mean a combination of physical shading and or a selection of appropriate glazing. Thermal bridges. A thermal bridge is a localised weak spot in the envelope of a building where heat losses are substantially greater than the surrounding areas. This weakness is a result of insufficient insulation and could be a repeating element such as a structural column or a continuous element such as a lintel, or the junction of two primary elements such as the wall and floor. Careful detailing is required to ensure thermal bridges are avoided where possible, although this can be more challenging in existing buildings. Ventilation. This means providing optimum indoor air quality for the health and comfort of users while avoiding uncomfortable drafts and associated heat losses caused by excessive uncontrolled ventilation. In practice, this means using mechanical ventilation with heat recovery, MHVR, to extract from rooms with high humidity, like bathrooms and kitchens, while supplying fresh preheated air to other areas like living rooms and bedrooms. Next slide, please, Jen. Enerfit. Enerfit was launched by the Passive House Institute in 2010 as its target standard for retrofitting of buildings. It uses the same methodology as the Passive House standard, but with a slight relaxation to reflect the complexity of existing buildings. It uses the same 5 principles to ensure that the design proposals address all the key aspects of building performance. Applying these 5 measures means buildings are designed to achieve specific performance outputs for a range of measures such as space heating, cooling demand, space heating, cooling load, frequency of overheating, frequency of excessive high humidity, air tightness, and so on. Retrofitting of the existing building stock will go a long way to achieving the net zero carbon target set by the Climate Change Act. Next slide, please, Jen. As well as the fabric first approach explained earlier, low carbon equipment plays a key role in providing the necessary efficiencies needed to achieve ultra low energy performance in buildings. A few examples. Photovoltaics, which means light electricity, is a direct conversion of light into electric power. There are 3 types of solar panel: monocrystalline, most efficient; polycrystalline. There are 2 systems, grid connected and off-grid. Generally, PV modules will last more than 40 years, require little maintenance, and usually come with a 25-year warranty. However, solar inverters, which convert solar AC to grid AC, might need replaced after 12 to 15 years. Airsource heat pumps convert solar energy from the outside air into electricity, which is used for heating. They use the ambient air to heat up your home and can be used for both hot water and space heating. Two types, air to air and air to water. Air to air heat pumps only provide space heating. Air to water, on the other hand, can provide both space and water heating, making it the most versatile heat pump type. For this reason, it's the most used type of air source heat pump in the UK. Both types work in the same manner. However, with the air to water heat pumps, the heat gets transported to the wet central heating system, such as radiators, underfloor heating and showers. Ground source heat pumps. The ground source heat pump extracts heat from the ground to heat up your home. It can be used for both space heating as well as water heating. A mixture of water and antifreeze is pumped into the ground via the heat pump, and the antifreeze mixture is continuously warmed up by the constant temperature of the ground. The liquid is fed into the heat exchanger, and energy absorbed from the ground is transferred to a refrigerant, which boils at a low temperature until it turns to a gas. The gas is fed into a compressor, and the compressor process makes the temperature of the gas rise. This is then fed into a condenser, which is then distributed to the wet central heating system of the house. District heating. This is a system for distributing heat generated in a centralised location through a system of insulated pipes for residential and commercial heating requirements, such as space heating and water heating. The heat is often obtained from a cogeneration plant burning fossil fuels or biomass, but heat-only boiler stations, geothermal heating, heat pumps and central solar heating are also used, as well as heat waste from nuclear power electricity generation. Biomass boilers. Biomass boilers are very similar to conventional gas boilers that you will be familiar with, providing you with space heating and hot water for the entire home. But instead of using gas or oil to produce the heat, they combust sustainable sourced wood pellets. Using wood in place of fossil fuels helps to prevent long-term climate change, since the carbon dioxide released during the combustion was absorbed while the tree was growing, so they are essentially carbon neutral. That concludes my section of the presentation. I'll now pass you on to Pamela to continue.
Thanks very much, Andrew. So I will just get started. So we've been hearing that we have the standards that we need to create a resilient and adaptive built environment that will help to achieve the net zero goals of the future. So we know what we need to do. The question now is, how do we do it? How do we overcome that inertia over the last 10 years that Tom has shown us, and the progress of the efficiency of the building has slowed? We've heard today about the proportion of our existing buildings that are poorly performing, and that 26% of the UK's carbon emissions are attributed to the built environment. And that figure is about 40% globally when you also include some transport infrastructure. A figure I heard yesterday is that of the long-term goals declared at the NDC, and NDCs are nationally determined contributions, so these are the efforts that each country has committed to with regards to reducing their emissions and adapting to climate change. So of that sort of 26 to 40% that is attributed to the built environment, only 20% of the commitments actually cover built environment. So the challenge ahead is going to be how we begin to view the built environment as part of the solution and not just part of the problem, and reframing our thinking about the measures involved as investments rather than a cost burden. So in the wide context of the built environment, there are many drivers for change. The policy drivers that we've already heard about from Tom, Kerry and Andy this morning will provide a framework for what needs to be done. Then there's also ethical and social factors that will primarily influence sectors such as the social and affordable housing sector. Not only is upgrading of our building stock the right thing to do environmentally, it's also necessary to protect the occupier. There's a long-established relationship between poor housing and health, And in a report by BRE, it's estimated that the total cost burden of poor housing on the NHS is £2.5 billion per year in the UK. And the same principles will extend to the creation of a healthy workplace. A transition to better insulated buildings and renewable heat will not only create a better living and working environment, it will ease fuel poverty and shelter bill payers from the energy price increases that we see across the UK at the moment and across Europe and the world as a result of the volatility of supply. It will also create green jobs, which the government's telling us will be 440,000 by 2030. We'll see if that happens, but that creation of jobs will remove one of the barriers that there's been to progress up until this point, and that is the skills shortage. For almost everyone, though, the most powerful and tangible of the drivers will be action-oriented change by financial drivers. So the bullet points I have here for your economic drivers are a little bit sparse and vague, and that's reflective of the developing state of the green finance agenda in the UK and globally at the moment. Some products such as green mortgages, which Tom mentioned, and sustainable defined contribution pension funds, which I do struggle to say, are emerging because investors are pushing the sector to manage more resilient portfolios. So if you managed to catch any of the events at COP earlier this week, you'll be aware of the shift that is occurring and the growing momentum in this area. So when I say economic drivers here, I don't just mean the cost of carrying out environmental or sustainable improvements, although if we're to zoom in and focus in on retrofitting for a moment, I'm sure that would be a very pertinent factor for most of you today. But staying in the wider context of the built environment, it's about the role of the financial sector in influencing and facilitating investment in our building stock and technologies to ensure that they're resilient and fit for purpose in the net zero future. So as I said at the beginning, we need to take a look at the cost. We need to look at the cost of investment in our built assets. And at the end of the day, if action isn't taken to protect those assets, their value will begin to diminish and they won't be attractive to domestic or commercial occupiers. Come to the next slide, please, Jim. So the approach, whatever your motivation is, how do we actually go about reducing the energy consumed in our building stock and thus reduce our emissions? So the heat and building strategy, which has been mentioned already this morning, I think, identifies 3 key types of intervention: improvements to energy efficiency, measuring, controlling and optimising energy use, and using low carbon sources of heat. So these are given equal importance in the strategy, reflecting the need for a whole system or whole building approach, which includes not only the building structure itself, but how those buildings are used and how the equipment within them are used by its occupants. As part of the energy assessments that we conduct at Graham and Sibbald, we consider each of these aspects in unison, recognising that the savings benefits are linked to and reliant upon each other. There's no point in fully insulating a property and installing a nice expensive renewable heat system if poor behaviours in the building mean that users are leaving all of the lights on and perhaps running heating and cooling equipment simultaneously. So following assessment to gain understanding of the current energy consumption and usage patterns, key interventions can be prioritised. The energy hierarchy and, to be frank, common sense dictate that we reduce energy demand and improve energy efficiency first and foremost. Configuring buildings and the people that use them to use less energy will be fundamental to meeting the net zero challenge. Relatively small, and I emphasise the word relatively here, relatively small investments in building fabric upgrades and installing more efficient equipment may provide some easy wins, which can quickly and easily be implemented with a fast return on investment. For example, we often see that upgrading lighting sources and their controls in commercial buildings can pay back within a couple of years or even less in some occasions. The actual cost and whether or not it's perceived as a small cost is of course relative to each individual situation and budget. Renewable energy generation should ideally be considered after these primary steps. And I've split renewables out into decarbonising heat and on-site microgeneration. placing decarbonising heat as the priority, as given what we've seen in terms of the proportion of emissions arising in heating buildings, renewable heating measures will in many cases have the greater impact in terms of overall emissions reductions. So it's important to emphasise that installing heat technologies such as heat pumps or biomass boilers should only be considered for buildings that have a good level of insulation. This isn't because these technologies aren't capable of heating our homes or workplaces, but because they deliver heat in a different way than what we're used to with our traditional gas boilers. So as a nation, we're used to turning on the boiler when we come in and turning the temperature up, and we get our heat nice and fast and benefiting from it within minutes. It's very responsive. But with heat pumps, by contrast, they deliver a low temperature of heat. Therefore, it's important that users understand how to operate the heat pump system efficiently and effectively to avoid it costing more to run than alternative systems. And this is where behavioural interventions also come into play. So to maximise the efficiency of, for example, an air-to-water heat pump and deliver sufficient heat to create a comfortable environment, radiators with larger surface areas or underfloor heating are required, which are designed to heat the building using water flowing at as low a temperature as possible, so ideally 35 degrees, rather than conventional heating systems which run at about 80 degrees. Increasing the water temperature to deliver increased space heating just won't work in this system, and it will just reduce the efficiency of the heat pump and result in higher energy costs. Biomass boilers may also be a suitable replacement for fossil fuel powered wet central heating systems, as they can be designed to generate heat and water at a range of temperatures, pressures and flow rates, and so are more likely to be compatible with integration into the existing plumbing and radiators that you have without major modifications. So in that respect, they have a slight advantage over heat pumps because your capital costs will be a bit lower and the disruption will be less. But it needs to be considered that these systems they operate differently to fossil fuel systems, such as current gas boilers. The combustion of the solid fuel can't change as rapidly as the combustion of gas, so they don't react as quickly to rapid change in heat demand. So therefore, biomass boilers are most efficient when operated continuously at a steady or low changing levels of output. A very important thing to consider with biomass is that they require adequate outdoor space and the capacity to receive and store biomass fuel, which, as Andy pointed out, should be sourced sustainably from a local supply to keep emissions low. And they also require regular maintenance, so they're not going to be suitable for all householders. Some other on-site generation, which I won't go into in too much detail because Andy's already been through it for us, but we also have solar or wind technologies that can be considered. But if you're looking at a technology like that, it's important to also consider the operating hours that you have for your business. So for example, if you are an organisation that primarily uses most of your energy in the evening or at night, then solar is unlikely to be a viable option for you without installing expensive battery storage, because the sun is generating that energy at a time that you can't use it. However, if costs in battery storage come down in future, this might become a more viable option. So at the bottom of the energy hierarchy, we would have carbon offsetting, which I've not included here. It would be treated as a very last resort for the residual emissions that are hard to mitigate. And just want to stress that if offsetting was an opportunity that was to be pursued, it has to be done with integrity and transparency to avoid being accused of greenwashing, which we're hearing being declared quite a lot these days. So while it might be more exciting to install on-site renewables or plant a small forest to offset our emissions, and these are certainly excellent ways of reducing and drawing down carbon emissions, which just happen to make for very good PR and social media posts, the key message, which I echo from Andy, is fabric comes first. So it's boring, but it's required. Have the next slide, please, Jen. So I'm not going to spend too much time looking at this slide. It's just to give you a visual representation of the way that energy is used across different commercial sectors in the UK. So this graph represents the energy intensity with the metric of kilowatt hours per metre squared. So it's a good relative comparison for the different sectors. And you can clearly see that where there's the deep blue sections, that the heating is primarily the focus of energy intensity across all sectors. We don't have time today to look at each of these in detail. I think we're already running over our time, but if anybody does have a particular sector that they're concerned with and would like to discuss more, then I'm happy to have a chat offline and you'll get my details at the end of this presentation. Have the next slide, please, Jim. So this pie chart that we have here is an overview of energy consumption in the retail sector. So I'm just going to have a very brief look at a couple of case studies from the top three of those sectors that we'd seen in the last slide. The information presented in the graph is representative of the UK as a whole, so the values there are in gigawatts per hour. So it's not that each individual company is using this much energy. However, it does give a good indication of the breakdown of energy use in the different sectors. That should be typically quite representative. So in food retail, then most intensive equipment comes, or use of energy comes from heating, refrigeration equipment and lighting. So I would just very, very briefly touch on some of the opportunities that there might be to reduce the energy demand in refrigeration. So there's obviously the opportunity to upgrade refrigeration equipment to some more modern energy efficient equipment, such as you might find on the energy technology list. But if that's not a feasible option for you, then there are other smaller measures that you can take, such as installing doors or curtains on open fronted display fridges, ensuring that the fridges are properly stocked, they're not overstocked, there's plenty of space for air to flow around them, and that the appropriate temperature is set for the produce that's in them, as well as ongoing maintenance to make sure they're always running at their best. So these individually have small savings, but it does all add up to a greater overall saving. Come to the next slide, please, Jim. So what we have in this table here is a summary of the average savings that we found in the retail sector from the last 5 energy assessments that we've done in that area. So retail industry is facing difficult challenges at the moment, particularly in high streets and shopping centres where reduced demand is causing prices to fall in property. This has resulted in lower capital investment in the properties, and equipment over time just isn't getting upgraded where it needs to be, and the buildings themselves aren't getting investment that they need to make sure that they're as sustainable as possible. However, if investment can be made, the savings in energy consumption can help to increase the profitability of the stores while going some way to protecting the value of the asset. In this table here, we can see that there were multiple opportunities explored, and in total those give us a sort of aggregate improvement of around about 75%, with a payback averaged out at 6 years. So there are plenty of opportunities there. It's just about being able to plan them in and access funding to perhaps be able to take them forward. Can I have the next slide, please, Jen? So although there have been some changes in the wake of the pandemic and the rise of home working, the office sector hasn't been as affected by asset value pressures as the retail sector. Increasingly, this sector benefits from a green premium, with workspaces with good environmental credentials and facilities increasing a sense of well-being and making it a more desirable and therefore marketable workplace. 82% of employees surveyed wanted to work in a green and sustainable space. However, currently only 16% of office stock is rated as good or outstanding by BREEAM, and I'm told only 2 offices in Glasgow have achieved excellent rating in BREEAM, although I haven't checked that figure, so I'm hoping it's a bit more than that. So there's lots of opportunity here to be had for office landlords to represent an attractive facility with low running cost while optimising the value of the asset. So again, you can see that heating predominantly, and obviously, as you'd expect, the running of IT equipment are your main energy uses here, and then followed by lighting. So There would be opportunities there to make upgrades to equipment, but also fabric improvements will help to reduce the running costs of the heating appliances that you have in there. Having good building system controls, perhaps taking away the control from employees of being able to turn up the heating themselves, because you do sometimes end up with a bit of a war in the office as to whether it's too hot or too cold, and make it differences as well. Can I have the next slide, please, Tim? Okay, so again, this table here is an average of the last 5 surveys conducted for office spaces. And in this one, lighting doesn't provide as significant a saving as it did for retail, but that's simply down to it having less of an overall consumption to start with. So there are more significant savings likely to come from building space, from fabric and space heating upgrades. And there may be opportunities for renewable energy generation, such as solar panels as well, with any energy that's generated outside of office hours, which could be quite significant in summer, potentially being exported back to the grid under the Smart Export Guarantee. The next slide, please, Jim. So with hospitality, clearly the biggest energy user is going to be from the catering equipment. I think we could have predicted that without looking at the slide, but it's also from space heating and cooled storage. The opportunities for improvement will very much depend on the type of business and building, but there are plenty of options to explore. So rather than go into them quite generically, as an example, I'm going to take you through a real world example of savings that we identified in a bar or restaurant on an energy assessment that we carried out a few months ago. So next slide, please, Jen. Okay, so this particular premise was located in a traditional sandstone building on the Isle of Arran, and it was within a conservation area. There was no mains gas supply on Arran, so space heating and hot water are provided by quite expensive electric appliances. The annual energy supply costs were amounting to about £12,000 per year, and that's excluding standing charges, so that is literally just the energy that they're consuming. I haven't included standing charges here because energy savings won't actually bring that cost down. Their emissions were equivalent to 18.2 tonnes per annum. So we carried out our assessment of the site and considered the suitability of it for an air source heat pump, and determined that with some prior upgrading to the insulation of the walls and recommendation to reduce the cold air infiltration that they were experiencing from the doors opening and closing and being left ajar by customers, that they install some low energy air curtains. And if they took those measures forward, then there would be a sufficient improvement in the heat loss through the fabric of the building for a heat pump to be a viable option. They had sufficient space for it at the back, and if they decided to go for an air to water heat pump, which is what was proposed to them, then it would also provide them with domestic hot water, which they were currently having to supply through electric immersion heaters. So there was a saving to be made there as well, in terms not just the saving in the heating, but also the saving in the hot water. A more efficient cellular cooling system was also proposed, which offered good opportunities for the client to use free cooling, because in Arran it does get quite cold. They were in a good area to be able to benefit from the natural environment outside. That would allow their beer cooling system to operate more efficiently. It wasn't going to have to run to such a high capacity for such a long time. There's also an opportunity to recover some of the heat from the chiller system and use it to heat water in the tank in the neighbouring room. So that would again give them a further easing in the cost of their supply of hot water. And the opportunity to install solar panels on the roof was also considered, but it was ultimately ruled out because of the prominent location in the conservation area. It just wouldn't have got planning permission. Alternative areas different angles on the roof were all considered, but unfortunately due to shading risk, it just wasn't going to pay off for them. But it was worth going through the calculations to see if it is a consideration, and if anything changes for them in future, then in terms of trees being cut down or what have you, then they've got the opportunity to pursue then. The easiest and least disruptive of the options are the replacement of aged and inefficient refrigeration equipment and gas discharge lamps. So those each offered, or combined offered, a saving of over £1,000 a year, and the replacement of the lighting equipment in particular would pay back within 1 year because they had quite a lot of halogen lamps around about the bar. So all nice, easy wins there that really should be taken forward straight away. They're a no-brainer. So as you can see from the savings table that we've got there, the gross savings amount to 14.1 tonnes of carbon a year. So it's certainly not insignificant. A word of caution on the information in this table, though, is that the savings are calculated against each individual measure. But in reality, if you were to implement each of these, they would impact on each other. So your actual real life savings might be a little bit lower. And the last slide, please, Jim. I'm not going to go into this in too much detail. It's just to give you a very quick hint at some things that you need to consider, a few little bits and bobs when you are looking to implement any sort of low carbon measures or trying to create a net zero building. So depending on the structure of the building that you're in, it might be important to consider the heritage of it. We are very emotionally attached to our older and historic building stock. So therefore simply knocking them down and starting again isn't always going to be an option. Even if you've gone through the calculations and you think that it's the most viable thing to do, you might have a battle on your hands with the locals. So we should seek to sympathetically upgrade buildings where possible, and hopefully they'll be with us for another 100 years. And some things to consider when you're looking at new technologies or renewable technologies for heat pumps and biomass boilers, etc., to consider the space that's available for them. It's not just a case of having a gas boiler in your cupboard for these, so it does require a little bit more consideration. And also the delivery method for the heat. As I mentioned, with the heat pumps, you might need to install larger radiators or consider some underfloor heating to make sure that there's enough heat of that low temperature heat coming through to create a comfortable space for you. And I'll just quickly touch on the barriers to success. Awareness and competency are certainly just the fact that these things aren't always considered at the point that you're maybe doing some other work, as Andy was pointing out. Behavioural barriers, just basically you need to bring your staff along on the journey with you to make sure that this equipment is used as effectively as possible. But the economic factors are probably the most significant because it's not cheap to do, but there are lots of funding programmes already available and coming to the fore in the next few weeks, I would expect. And I think at that I will leave it and I will hand on to Marie Macklin from Halo, who is going to talk to us about the project that they've been working on there. Fantastic building. Thank you very much.
Marie, sorry, I think you're muted. Is
that me? That is? Okay. Thanks very much, Kerry and Sibbald, for the invite this morning, and Jennifer, that was a really good presentation, especially around policy, ethical, social and economic barriers. I'm going to explain a bit about the Halo Urban Regeneration Company. I think we're tackling some of those issues, and somebody will kindly keep forwarding my slides. So if we could go to the first slide, please, that would be great. So the Halo is 13 years in the making. I used to have a company called Clin, and I've got a company, Macklin Enterprise Partners, an investment company, and we came together to create Halo Urban Regeneration 13 years ago. And we believe in creating a new tomorrow's world for our children's children, built around people. And the first site that we took control under that banner was the 28-acre Diageo site, formal industrial site in my hometown of Kilmarnock, where I grew up. And many of you know that Diageo exited in 2009, and we faced 700 job losses. So for me, what do? Do you stand back and do nothing, or do you drive something new forward? So it's took us 13 years, and a lot of the issues have been around about policy, ethical and social, and economic issues. But we believe in the power of the people. And if we talk about that word people, then we have the power at this moment in time in our hands to make considerable changes in how we look at future developments regarding that green recovery. We have got energy provisions there that sometimes are costly to put into the development that I'll speak about. We have got this opportunity to change people's lives forever and green upskill and realign actually coming out of COVID-19 how our communities want to be going forward in the future regarding economic benefits to not just cities but towns in particular and rural economies. And we talk about this planet and we talk about the word love, and you hear me talk about love a lot in my developments, because if it wasn't for the people that were behind them and the people that marched, there were 20,000 has marched that day to save those jobs, we wouldn't be currently having this £65 million project that we currently have. And at the end, it's all going to run into giving employment opportunities. So it's a £65 million development built around live, work, learn and play. There's a health, energy and enterprise strategy. And it's all about creating jobs built around a net zero economy. So for starters, on this development in phase one, the 50,000 square foot centre that you see in that picture, it took us 13 years and basically to pull finance together to make that work. The government back then in 2009 said that they would put £10 million into a viable proposition. And that was fine words, but when it came down to it, it was very severely lacking in actually offers. So we managed to pull a deal together through the Ayrshire Growth Deal strategy, where we put in a private finance supported by £3.5 million from UK Government for innovation, £3.5 million from the Scottish Government for infrastructure, £2 million from the Council, £2 million from Diageo, Johnny Walker's, and they donated the site to come up with a community proposal. We currently on that site will open in January, and the building is built, and you'll see it in some of the pictures later. So environmentally wise, we excavated and crushed 20,000 cubes of granular materials and 10,000 cubes of subsoil. And that's going to be reused in part of the urban skate park for the young people that when we went out into that community, I'm very community driven. What do you want in this site? There'll be an urban skate park. We're all about the solar element of the building. We entered into a 5-year partnership in 2018 with Scottish Power. And Keith Anderson and the amazing Scottish Power team had heard of Halo and said, what can we do? And we came to the conclusion that on this site, it should be Scottish Power's first testbed site, who are part of the Iberdrola group. So we are one of 5 projects worldwide. There's one in Bilbao, Murcia, Brazil and upstate New York. So from that agreement with Scottish Power, and it was all over the press, we were awarded £1 million a year between services and cash to use the site as a testbed site. Within this building, that then resulted in Scottish Power and Halo coming together through the grants that they gave us and our private finance. And we have collated a solar system. On the building roof, there's 35,000 kilowatt of solar power. On the carports, we have carports for electric vehicle, bus and bicycle stations. There's 25,000 kilowatts, which equates to obviously 60,000 kilowatts. We have a 460,000 base kilowatt load, and we're now generating probably in the region 15 to 16% from that energy provision. which equates to about 16 homes in general. There is a huge, next slide please, there's a huge battery backup system that you'll see further on in the slides, which is 50 kilowatt. And we are currently using a system called Passive UK System software. It monitors the best times of the day when we should be pulling energy from the grid. So hopefully when it's sunny, then the sun affects the solar, but then when we basically buy in, and we've been negotiating this week for a fixed term contract at the lo and behold of Vladimir Putin, with the price structures, and today we've actually signed up for a year. But what we're hoping to do is pull as much energy and store it into this system that we currently have. I should say that we are a BREEAM Excellent rated building. The award should be awarded very, very soon. And when I started this journey, it was all about giving my hometown that aspiration that we could create a state-of-the-art building that you would see normally in one of the major cities. And this has only been possible because of the partnerships that we've managed to create along the way. And that goes back to, in particular, our Scottish Power Agreement. When we talk about test bed, there are going to be 210 homes on this site. I was interested to come in partway through about the passive home situation. We're working with a social housing provider and our own brand, Halo Homes, for the private rental sector, that will be at the forefront of technology, healthcare provision, and that sustainability, where we're going to be using the ground source heat pumps system. So, as I say, it's been a 13-year journey for us. If somebody had asked me 13 years ago we would be at the forefront of this new economy, I wouldn't have believed it. I think for us as well, we talk about active commuting. In the face of COVID, there's more people working from home, and that's where we see our developments coming into a main provider. For me, with our developments, it was never about building, in particular, a shiny building. It was about what can we drive out of that building. So it is going back to skills. So through the Scottish Power Agreement, we have an element of that finance for reskilling and upskilling their current workforce, and bringing in young people who will be based at Halo and the innovation department at Halo that we employ, that we will be allocating through a special Halo digital and cyber course wrapped into energy provision and healthcare provision. And these young people will work with some of the best companies that we have in there. We have the first Eagle Lab based outside a city in Kilmarnock, again working in conjunction with them on their green agenda. We have a special green department, and that's for growing businesses, scale-ups and start-ups and established businesses. And for me, on that 15,500 square foot trading floor, it's about bringing a green hub. We're going to be creating a green hub in there for SME businesses. Because I think for me at a COP26, the fear that I have is I most welcome this event being in Scotland, but what we must not forget is about our outlying communities, and in particular our young people, our lost boys and girls who have maybe fell off one ladder at school and have not been able to get to college or have no aspirations to get there. We need to make sure we create opportunity. And I see the Halo brand creating that opportunity. So putting it at the forefront of innovation as a building will in turn then create opportunity that we speak about in economic drivers for young people and innovative businesses that want to start up and scale up at Halo. Can I have the next slide, please? You'll see from these slides that I've asked our chaps to put in some of the standards that we have, our wireless forward connectivity for our comms. We have a huge partnership with Comms World. So I firmly believe to make this development work, as much as it was building the building, it was bringing in PLC UK and worldwide and saying, can you come and help us? Can you come in and sponsor some of our facilities so that when we have the 15,500 square foot trading floor, we can offer services free. So Comms World, for example, have came in and are giving us free Wi-Fi for the whole of that building. That is a cost reduction for the Halo Rock Me brand. We have, as I say, Eagle Labs based there through thriving local economies, and again they are paying to be there and a wraparound service for these growing businesses and in particular young people through our Kickstart programme, where we are taking on 200 young people, 16 to 24-year-olds who are in universal credit, and aligning them with some of the businesses that are in our building on opportunity and job creation and a new skill base. We talk in here about future-proofing the building. I'm pleased that we're going to be announcing, that can exclusively reveal on Tuesday, a major announcement that Graham and Sibbald have been at the forefront as their agent, Fraser Lang and his team. We have 2 floors that equate to 13,500 and 15,500, and we have a major NASDAQ company that we're blown away with our sustainability of our overall site and building, and we'll be announcing on Tuesday that they are entered into a 15-year lease at the Halo, and not just coming in as a tenant, but buying into the Halo Rock Me concept, where they will be working with us and our innovative businesses upstairs and our young people in creating future jobs and skill base at the forefront of Kilmarnock and Scotland. We have got secured a dedicated comms room. We have facilities in there for emergency, for the batteries and comms that they require. We've got the driving points for cabling, so we've got 2 cables going in. If one cable goes down for whatever reason, phone system, the other system's there. So we have basically worked tirelessly with our consultants on the Halo concept. We have got the 210 homes that will be coming in very, very soon. As I say, we're working with a housing association and we want to retain our own. We have, can the next slide please? We have an EV car club. So on the car club, you'll see that we were awarded a grant of just under $500,000 for electric vehicles, and included in that is the Halo bus that you see there. That bus is for the tenants that will drive into town. They get that free of charge. Arnold Clark has supplied us 2 electric vehicles that we are currently testing, and we see that our housing provision will be sustainable homes where you rent your house, you rent your car, you rent your white goods, and they're renewed every 5 years. And the data that will come from everything that doesn't move in the Halo Urban Park will then be monitored by Scottish Power on future products and assist with fuel poverty. So again, that is a first for Scottish Power and Iberdrola. In the next slide, please. This is just some of the facility. That's the battery that I spoke about earlier, the Halo bus. We had on site, this project's now become international status. We had the energy chairman of the Israel Energy Corporation and the team on site on Monday. We then took them up in the bus to Whiteleys Wind Farm, where our energy is sourced from. And to coin a phrase, they were blown away. We actually, the type of facility and the fact that we are not just looking at this as a building, we're very much driven on the community aspect from bottom up and the skill bases. And as I said earlier, for them, they've now invited us into Israel to look at what they're doing. They're at the forefront of digital cyber. We could learn so much from them and innovation, but with their energy, as they say themselves, they are very, very far behind. And they like the idea of our Halo Rock Me Club for Innovation and our Kickstart scheme for our young people. We, next slide, please. This is just what I had to do with the site was take away the stigma of the Diageo exit and put Ayrshire and Kilmarnock at the forefront of something new. And that is a very difficult thing to do, but we've got an amazing team. So we basically have realigned it. It's the Halo Digital and Cyber Innovation Park. So out with the housing strategy, there is light manufacturing digital units getting built. There's live work homes where you can live at home and have your business at home, a type of concept that I saw in America. There is, as I say, light manufacturing, digital high street of the future, looking at digitalisation and innovation, and how do we work with some of the amazing independent shops that we have in the high street. The high street needs to realign itself. The days of the big box are long gone. So we want to work with independents in some of these listed buildings that Jennifer spoke about earlier. And if we're going to really get real about this, we have great organisations at government level, but if we're looking at policy and planning and legislation, and in particular organisations like Historic Scotland, in order to reach our targets, something has to give. And we can have all these COP meetings and everybody can come and say what they say, but on the ground, most of you in this call have dealt with various planning legislations. It's a difficult call, and we have managed to get through this 13-year journey because we had a fantastic council that believed in us and believed in the product, and through by hook or by crook we finally got there. And I think developers need to look at the big question here regards finance. Jennifer spoke eloquently about finance earlier, and for me the hardest thing was, how do you fund this type of project? Yes, we're in business to make money, but we're in it for a long game. We're not in it for a quick fix. So this project will make money, but no if it's a flip type project. So as much as I welcome Mark Carney's position, we seem to be talking about the big global cities here. We need to get down to brass tacks and start talking about how it actually affects SMEs in our local communities that haven't got the budgets to implement some of the systems that are required to be implemented, or have the knowledge through no fault of their own. So governments have to, and enterprise agencies and councils, look at how we're going to support these types of communities. And as well at schools, we need to get kids integrated earlier. We're building a children's innovation hub. We should be learning our young people from in nursery school in more depth about digitalisation and taking that forward into the energy provision. I mean, we're working with a local school, Hillhead Primary, and a deprived community at the front of sustainability, and it's kids like that that I want in my building from primary 1 right away through to secondary school, because that's where the knowledge base will start. So we're very much about taking urban sites. We hopefully will be announcing January, February, a major announcement for Glasgow on sustainability and the Halo brand. We are currently in Belfast, with sites potentially in New York and over in Spain. And we want to take the brand throughout the UK and share our findings, like what we've offered to the Israeli government on Tuesday, which they have taken up. So I welcome this opportunity. I think that we can do it, we can reach net zero, but there needs to be hard discussions after COP26, especially with banks and financiers coming together with the real world of what we all work in to reach that net zero target. So thank you very much.
Thank you, Dr. Macklin. So just now time to wrap up, I think, and just thank all the speakers for your fantastic presentations. We've heard from a number of different disciplines and personal experiences in terms of project developments and energy efficiency gains, as well as from planning and from architectural services, if you like, the building standards developments that are going on. What we started with there was a discussion on the fact that the built environment does contribute a significant portion of the UK's carbon emissions, about a quarter of that, just over a quarter, that we have to achieve a 41% reduction in carbon emissions over the next 13 years in order to try and meet that interim target for net zero in the UK. And that's going to present us with some significant challenges and opportunities. So what have we got going for us then? The discussions concluded that we have, first of all, in the UK, a legally binding target. Now, UK is only one of 6, I think it is, 6 countries around the world who made legally binding targets on net zero. That's concerning. So we've got 195 or so nation states in the world. Only 6 of those have committed to legally binding targets. That needs to change. Hopefully we'll get more news during the course of this COP26 that we'll get more signed up to become legally bound. We've also increased by 2019, we increased the initial target of 80% reduction in emissions to a net zero target. So the UK definitely has ambitions, but it has a long way to go. We've introduced a number of regulations already, and further regulations that have been discussed today are forcing the elimination of fossil fuel dependency, which is a key to decarbonisation naturally. We've got mandatory and voluntary standards developing. We've discussed those in planning and building standards that are going to lead to zero emission design, construction and zero emission existing building stock in the medium to long term as well. We've got incentives that are going as well, as we mentioned the carrot and the stick earlier on. Ofgem have been running environmental programmes for about the last 15 years, putting billions of pounds a year into renewable and energy efficiency projects. You may have heard some of the names: renewable obligation, which is focused on energy generation or green energy generation schemes, the feed-in tariff that used to apply to solar panels, ECO, renewable heat incentive, focused on supplying renewable heat to both domestic and non-domestic properties. The recent boiler upgrade scheme, so criticised for its limitations in terms of the amount of funding that's provided, but it is a seed fund. It's getting the technology into the market at industrial scale, so that should be encouraged. Hopefully we'll get more of it. Zero Waste Scotland and the CARES programme, some of the stuff that Pam and I are involved in on a day-to-day basis, sees small to medium-sized enterprises being supported to carry out energy efficiency surveys, and following that, the eligibility of reasonable measures are then funded either by 0% loans or by grants. So again, there's funding and there's incentives available if we know where to look. Looking at minimum energy efficiency standards we discussed earlier as well. In England and Wales at the moment, it looks as if we're going to be introducing increasing minimum energy efficiency standards for buildings that are let by private landlords, and the requirements to actually improve the efficiency of a building pre-letting. For example, moving from grade E EPC rating to a grade D EPC rating minimum by 2030, and even grade C by 2035. So there's a great deal of pressure being applied now to landlords in non-domestic properties as well. Renewable energy supply, we spoke about that earlier, the efforts made and the successes in decarbonising the UK's electricity supply. We're at this point in time about 40% renewable electricity in the UK, and another 15% in nuclear generation, which takes us up to about 55% in total non-fossil fuel related electricity. The anticipation is that by 2040 or 2042, the entire grid is going to be supplied by green electricity. That might sound ambitious, but if you look at the Scottish figures alone, actually in Scotland we generated enough electricity from particularly wind and solar generation to match 97% of our demand in Scotland last year. So we're almost there in Scottish terms. And then innovation. We look at innovation in building automation, controls, solar technology and heat technology, and the efficiencies that scale will bring to that equation, and the cost reductions that will come as a result of that as well. I like to relate this, people call this now the third industrial generation, and if we look at the technologies and the innovations and the efforts of people in this sector at the moment to where I was about 35 years ago in the electronics industry, and a gentleman called Gordon Moore, who founded Intel Corporation, came up with a wise set of predictions, if you like, now called Moore's Law, back in 1971, and those predictions have actually stood firm for the last 50 years. And those were about the fact that he anticipated that the amount of transistors that you would place on an integrated circuit would double every year, or every 2 years rather, and you would be able to achieve that with the same cost as 2 years prior. And every 2 years, the doubling of transistors for the same cost, that's continued for the last 50 years. And so that's why we have mobile phones now that have the power of supercomputers from 20 or 30 years ago. We're going to see the same advances in solar. We're going to see the same advances in heat technology as well. So there's hope out there. We've got a long way to go, but there's certainly hope, and we anticipate that this is going to be an industrial revolution to enjoy for the next 20 or 30 years. So thank you very much, everyone. Jen, do we have any time for questions, or do we need to close now?
We have unfortunately run out of time for questions. Thank you to everyone that has submitted one. What we will look to do, as mentioned previously, is we'll look to get responses to everybody for the questions that have been asked. But with that, we will let everybody enjoy the rest of their afternoon, and thank you very much for joining us today.
Thank you.
Thank you.